Hello and welcome to the Humanoid Leaders series. Today, I'm incredibly excited to be joined by Rob Mastromattei, the Chief Commercial Officer at Allient. And today, we're going to be taking a closer look at humanoid robot joints and how Allient technology helps support them. Thank you very much for joining me, Rob.
No, thank you for having me.
Could you please start by providing a background to yourself and Allient?
Yeah, Allient is a global corporation that focuses on three main areas: motor and motion control, and that would be the Allied Motion business unit. And then we have a power group, that Allient Power, that focuses on power controls, power conditioning. And we have a factory controls group called Allient Controls, and they focus on factory controls and communications. So I am the Chief Commercial Officer, and I play a role that coordinates sales activity globally and technical support. So the application engineering groups work with me. We focus mainly on pre-sale customer activity, and one of the biggest growing areas for us is robotics. And so humanoid robotics is probably within robotics is one of the fastest growing areas of robotics. One of our core products is motor technology, and we have really more motor technologies than any other motor manufacturer. So we have motors that run smooth, and motors that have big through holes, and motors that have high torque, and motors that have high speed, several different types. And I'm originally a motor designer, so I know a little bit about motors, and we really have quite a variety of motors. And especially for the humanoid robotics, having lightweight, large diameter, low profile, large through hole, high torque motors is critical for that application.
Perfect. And could you please now go into a bit more detail about what typically makes up a humanoid robot joint?
Well, the joint itself is, motor powered. So there's an electric motor in the joint. Depending on the size of the humanoid robot and how much weight it can lift, that joint may have a gear in it in addition to the motor. Of course, every motor joint has an encoder inside it so that the control system could figure out what the position is. And then in some cases, there are torque sensors in the joints because of the collaborative nature of a humanoid robot. And so the humanoid robots, the joint, again, starts with a motor. It's usually a frameless motor kit, or is it a torque motor, as some people say. And that motor, is specific to the size of the joint. All of them have a large through hole so that wires can go into the motors inside the humanoid, as opposed to wires on the external. So the basics of the robot joint. And then with humanoid robotics, there are a lot of joints. You're not talking about a 3 or 4 axis articulated robot. Now you may have 12 or more joints in a humanoid robot. And the interesting thing about humanoid robots is it's really a combination of a mobile robot and an articulated robot. So like the arm will move, in different positions like a articulated robot, but the whole body of the whole system has to move around to different places. And the nice thing, the differentiator with humanoid robotics is that, if it's a pick and place, so what they're lifting might move around, and the place that they put it moves around. So it's very different than machine tending, where the machine's always there, the tools are always there, the parts are in the same place all the time, so you can set up a fixed robot to take parts out of the machine when it's done. But with a humanoid robot, it's a combination mobile robot and articulated robot at the same time, and it probably has 12 or more joints in it.
Excellent. And so when engineers are designing their humanoid robots, what are some of the key considerations that the engineers should consider when designing the joints?
Well, the age-old, rule number one is heat is the enemy of torque. So in a motor, torque, you basically, in any robotic application, you're using the motor mainly for torque, because it's not only moving, it's not like it's a pump or a fan, it has to stop and hold. And especially in a humanoid robot, most all of the real activity comes when you strike a pose, just like a person. You bend down to pick up your wastebasket. You're moving to a certain position, and then you're holding there for a little bit, and then you're moving back. And so I think the design of the electrification is driven in that case by torque, and torque and heat are on the opposite sides of the equation. And so the biggest challenge that designers have is getting the smallest size that they need to fit into a package that doesn't look like a big bump on the side of the humanoid, and that they pick a motor that has high torque density because it depending on if you're lifting less than 10 kilograms, you can do direct drive, and if you're doing direct drive, it has to be smooth too. When you see a humanoid robot, it's supposed to look fluid as it moves. It's not supposed to be all jerky, and so smooth motion is important. Having the right torque output for the size and the weight, and any joint that's above the main joint is going to add weight to the robot that really doesn't impedes its ability to lift up a package. So torque, size, through hole, electrically it has to be compatible with whatever the electrical system is a battery or whatever. And then heat is generated. So, that's the ultimate limit in how much torque you can get, how long you can strike a pose far away from the body. So I think modeling is really critical when it comes to humanoid robots. It's not like you just select a motor out of a website and you click on it and it comes and you put it on your pump and it runs. It's not that. It's more about the whole system integration and how temperature plays a role in motor selection, as well as the physical motor and its characteristics.
Now, you touched on it in your previous answer, but could you go into a bit more detail about some of the common challenges that engineers are facing when designing their humanoid robot joints?
Well, I mentioned before that, the core of each joint is a motor. Allied Motion, which is a business unit within Allient, we offer motors from 8 millimeter diameter all the way up to well over 250 millimeters in diameter. Most of them are designed for direct drive or low profile, high torque applications. And so they're very much like a ring motor. So minimum weight, high torque, large through hole. We offer mainly permanent magnet motors, so permanent magnet synchronous motors, also called brushless DC motors. They're frameless and they're easy to integrate in to a joint with bearings and an encoder. They also work very nicely with gearing, whether it's planetary gearing or whether it's strain wave gearing or, high ratio zero backlash gearing, which is used in a lot of cases in robotics. So the motors are highly integratable, if you want to, that's a good word, with gearing, with encoders. There's a wide range. They operate we can have them down to 12 volt operation and all the way up to 800 volt operation, depending on the type of architecture the customer has. And then we not only do the motors, but we do customization for those motors. So if there's a unique requirement mechanically or a unique requirement electrically, we're right there to go with a special and provide that to the customer. And then the third thing we do is integration. So starting with the motor component, we can help the customer figure out how to fit it into the robot, and then we can take over the project and design the whole joint and build the whole joint. And we have factories in the US, in Europe, Asia, depending on where the end product is going to be and the correct location for manufacturing. We can produce the complete robot joint or a subassembly or a motor with a shaft, a motor with a special connector. If it's a special environment, we can take the motor and we can put it in stainless steel and laser weld it so that it can go into a vacuum environment if it's a robot in vacuum. So we have a wide range of products, and we also have an interest and a willingness to customize, and then not only that, take those products and make them into complete joints or subassemblies for the customer, fully tested, automated test comes in, it's all ready to go. But it's a customized solution because it fits their application.
That's quite an array of products that you offer to the space. And finally, could you please go into detail as to some of the other areas of robotics that Allient operate within?
What I said earlier is that the humanoid is a combination of a traditional articulated robot. We do a lot of those, selling components to the robot manufacturers. We also are pretty big in mobile robots, so robots that move around, whether it's in a factory for warehouse automation or whether it's on the battlefield where there's a mobile robot. We provide motors to those applications, and now the humanoid robot is a combination of those two. And so we work with full-scale, human-looking humanoid robots, And then there's combinations, right, where there might be a mobile robot with a humanoid robot on the mobile robot. So we are providing motors, motor assemblies, and drives also to those applications. Sometimes the drive's in the motor, sometimes the drive is somewhere else on the humanoid robot.
Well, Rob, it's been an absolute pleasure speaking with you, and thank you very much for your time.
We'll talk to you soon. Thanks.